Welcome back, everybody. We are going to start section 9.1 today, which starts our trigonometry. If I can spell it right here, trigonometry unit. Starting with the right triangle basics, just going over the fact again that your right angle and the side opposite is always your hypotenuse. We label our hypotenuse as side C. The other two sides are called legs, and those are your A and your B in Pythagorean theorem. Going back and revisiting a little bit from last year on your trig functions, we have a right triangle here. I'm going to mark an angle. I'm going to call it theta. That's a circle with a line through it. And the reason why I do that is because I don't really know what the measure is, but that's the angle that I want to talk about. If my angle theta is down in the lower left-hand corner, then I have my hypotenuse that's opposite that right angle, always going to be there, never going to change. The opposite side is going to be our leg over on the right, and the adjacent side is going to be the leg at the bottom. It's adjacent because it's touching our angle theta. If I drew a second triangle and I moved my theta to the upper right-hand corner, my hypotenuse is still in the same spot, but my adjacent side is now on the right because that's the side that's touching our theta, and the bottom side is now our side opposite. SOHCAHTOA, that's what we've been familiar with. And so that's what we're going to start with over here on the left. Sine. Sine is so. That means we find it by using the side opposite over the hypotenuse. Cosine, ca, the side adjacent over the hypotenuse. And then TOA, tangent, is the side opposite over the side adjacent. Now for our new ones, we have cosecant. Cosecant is abbreviated CSC. It is the exact opposite of sine. And when we're talking about opposites, like opposite operations or reciprocals, that's exactly what we're doing here. We're taking the opposite over hypotenuse and flipping it upside down. So it is the hypotenuse over the opposite. Secant is abbreviated SEC. It is the exact opposite or reciprocal of cosine. So we'll find this by hypotenuse over adjacent. And then cotangent, COT, is the exact opposite of tangent. And that one's kind of easy to remember because it's got the word tangent in it. And again, we're flipping that exactly upside down, and that's found by adjacent over opposite. So these are the 6 possible trig functions that we can find from a right triangle. So I'm going to try a couple with you. We're going to start here. Our right angle is over here in the corner. I'm sorry that it didn't end up getting marked when I translated this over. And then we have our theta over in the right corner. That makes 5 our side opposite. Our side adjacent is on the bottom, And then 13 is our hypotenuse. Well, I don't know what my adjacent side is, so that's the first thing I have to start with. And how do we find the side length of a missing side? We use Pythagorean theorem. A squared plus b squared is equal to c squared. I need my adjacent side, so I'm going to leave that blank. 5 squared, and c is 13 squared. A squared plus 25 is 169. Bring that 25 over. We have a squared is 144. And then take the square root. And we find that our adjacent side is 12. All right, so starting with sine, opposite over hypotenuse. And that's it. That's all I'm writing. You just want to write the opposite side is 5, the hypotenuse is 13. Done. That's our sine of theta. Our cosine of theta is the adjacent over the hypotenuse, and that's it. That's the ratio. Cosine of theta is 12 over 13. The tangent of theta, opposite over adjacent. And that's it. I'm not trying to do anything else with that. Tangent of theta is 5 over 12. Now that I know those three, I can go do my reciprocal functions. Cosecant. Cosecant of theta, take that fraction and flip it upside down. So it's 13 over 5. Secant of theta, take this fraction, flip it upside down. It's 13 over 12. Cotangent of theta, flip that upside down, and you have 12/5. And that's all that we're trying to do right now. Just find that missing side and write our 6 trig functions. Let's try one more for today. Let's do example 2. There's my right angle, which makes this my hypotenuse. 6 is the adjacent because it's touching where my theta is. And 10 is my opposite. The first thing I need to do is figure out what the hypotenuse is. So 10 squared plus 6 squared is equal to c squared. 100 plus 36. 136. 136 is not a perfect square. So I'm going to reduce that radical. 136 is even, so I'm going to pull out a 2. And that gives me 68. I'm going to pull out a 2 from 68, which gives me a 34. 34 is 2 times 17. So I have a pair of 2's. That's going to come on the outside. The 2 and 17 are stuck inside, so we'll multiply those back together. And we have 2 square root of 34. So I'm going to start with sine OH. That's 10 over 2 square root of 34. Now I do want to reduce that 10 and 2 and call it good there. Cosine of theta adjacent over hypotenuse. I do want to reduce the 6 and the 2, so that's 3 over the square root of 34. And then tangent, opposite over adjacent. And I'm going to reduce that to 5/3. So then my reciprocals, starting with cosecant. Cosecant, remember we flip sign. So that's the square root of 34 over 5. Secant is the flip of cosine. That's the square root of 34 over 3. And then cotangent is the flip or reciprocal of tangent, which is 3 over 5. And so then I have my 6 functions. We'll come back and do some more on this, but we're going to pause here for today. Have a great day.